Hey Noble, so I've got your most recent test here, and I'm going to go over the questions that you missed. These do require quite a bit of work, so I apologize in advance if this video gets long, but I'll try to talk it over pretty quickly. I actually went ahead and solved them ahead of time, and I've got my note sheet here next to me, just so I wasn't wasting time like punching numbers into the calculator. So the first question says an aircraft travels with the wind for 120 miles in 0.75 or 75 hundredths of an hour. The return trip is flown against the wind and takes exactly 1 hour. Which system of linear equations represents x, the speed of the plane in miles per hour, and y, the speed of the wind in miles per hour? Recall the formula distance equals rate times time. So anytime you have like wind resistance or a current on a river, I always set up a table. So in this case, we're talking about two instances. We're traveling with the wind and traveling against the wind. So I'll write two rows here with wind and against wind. And then remembering that formula that distance equals rate times time, and it's going to help us fill in this table. So it says the aircraft travels with the wind for 120 miles. So next to with the wind, I'm writing 120 under distance, and the time is 75 hundredths of an hour, 0.75. Then we have a return trip against the wind, and it takes 1 hour. And since we're not told any different distance, we're going to assume, since it is the return trip, that it takes the same path, and it also travels 120 miles. So the trick here is the rate, and it's understanding, first of all, that we've got two different variables that are going to describe the rate. We have the plane speed, but then we also have the wind resistance. So you have to make sure that you understand which direction, with the wind or against the wind, will make the plane go faster or slower. So we're given variables here, x and y. So x is the plane, and y is the wind. So if a plane is traveling with the wind, it's going its own speed plus the wind resistance. The wind resistance is going to make the rate faster when you're flying with the wind. That's why we put a plus sign there. When you're traveling against the wind, that's actually going to slow the plane down, make its rate slower, so that's why we subtract wind resistance. So the overall rate is less here, and the overall rate or speed of the plane is faster here. So distance equals rate times time. You're literally taking these pieces from the table, setting 120 equal to x plus y times 0.75. Remember also that when you're taking a number and multiplying it by an addition problem, a subtraction problem, an expression, we're going to use the distributive property. So 120 equals 0.75 times x plus y. And again, we typically write that number in front of the parentheses. So really this equation looks like distance equals time times rate, which is the same thing. Against the wind, again, distance equals the rate times the time. The time here is 1, so multiplying x minus y times 1 doesn't do anything. We can just write x minus y. You're welcome to put it in parentheses. You're welcome to put the 1 out in front, but you have to recognize when you see the answers over here that it is the same. So it looks like on yours, you might have done it exactly right. You just did distance times rate equals time instead of above distance equals rate times time and distance equals rate times time. So here's the correct answer. Okay, this next one is the one that is a ton of work. But again, I set it up very similarly to the last problem. Micah rows his boat on a river 4.48 miles downstream with the current in 0.32 hours. He rows back upstream the same distance against the current in 0.56 hours. Assuming his rowing speed and the speed of the current are constant, what is the speed of the current? So we have downstream and we have upstream. We're still going to use the distance equals rate times time formula to fill in our table here. And really you just look at each of these situations individually. So first we're going to focus on downstream. It says 4.48 miles with the current in 32 hundredths of an hour. Upstream, the same distance, but this time it takes 56 hundredths of an hour. So again, this is where you have to understand that traveling downstream is with the current. You're going to go faster. And you can use really anything here. We're talking about a boat and we're talking about the current. So I'm going to use the letters B and C. You could use X and Y as long as you know which one is which. And a lot of times in the problem I like to label them up here like this so that I can go back and say, oh yeah, B was the boat and C is the current. So again, downstream, you're going to be traveling faster. So it's the boat speed plus the current. Upstream is going to be harder or slower, so it's the boat speed, it's the boat speed minus the current. So the reason why this one gets so ugly is because of these decimals, but it's still distance equals rate times time. So 4.48 equals 0.32 times B plus C, and 4.48 equals 0.56 times B minus C. So in a system of equations, I am going to go ahead and divide both sides of this equation by 0.32, and I'm going to divide both sides of this equation by 0.56, and I'm going to show you what that does. So in my calculator, I actually am going to do this a different way than I did it originally in my notes. So I'm going to divide this side of the equation by 0.32, and it's going to cancel the 0.32s and just leave me with B plus C. But then I also have to do it on the other side. So 4.48 divided by 0.32 is 14. And on this one, I'm going to divide by 0.56. And I can show you here a little better because I have some more room. I didn't have room just above in the other one. So if I divide this side by 0.56, those cancel. And I divide this side by 0.56. So 4.48 divided by 0.56 is 8. And that's B minus C. When you have a system of equations, which we do here now, remember that you need one of the variables to have opposite signs and the same coefficient. And we have that already with the B and the C. You can see that one is positive and one is negative. So I'm going to add these two equations up. The C's are going to cancel. 14 plus 8 is 22, and B plus B is 2B. Divide both sides by 2, and we get that B equals 11. So when I go back to the question wanted to know what's the speed of the current. Remember that B originally represented the speed of the boat, which means that we want to plug that answer in, that 11, into an equation. Now, there are easier places to plug this in and more difficult. It's more difficult over here on the left because of the decimals. It's much simpler to plug that 11 in over here. And the easiest spot is this one. So 14 equals 11 plus C. Well, 11 plus what is 14? C equals 3. So 3 miles per hour is the speed of the current. Now I realize that that got really complicated. Most of these problems are fairly similar in their setup in terms of setting up the system of equations, because typically it's an upstream, downstream, or a wind resistance traveling with the wind or against the wind. So I'm going to keep going with, there's another system of equations type problem on here that you missed also, so we're going to go down to those next. So this question says, Addison earns a fixed hourly rate working as a sales clerk. If she works on a holiday, she earns a different hourly rate than she earns on a regular day. In 1 week, she earns $188.50 by working 5 hours on a holiday and 16 hours during regular days. A different week, she earns $254 by working 8 hours on a holiday and 20 hours during regular days. How much more is Addison's holiday rate than her regular hourly rate? So we're talking about two different things. We have holiday rate and we have regular rate. And I'm just going to use X and Y. And you have two situations, 1 week and the next week. So really you're just setting this up. $188 is what she makes total. So that's going to equal 5 hours a holiday plus 16 hours of regular pay. And again, remember that we don't know how much the hourly or holiday pay is. That's what X and Y represent, the cost. So in the second situation, $254 is going to be equal to 8 hours of holiday and 20 hours of regular. So to solve the system, again, we need a coefficient in front of the same variable that has an opposite sign. You can work with 16 and 20, or you can work with 5 and 8. In my opinion, this is a little easier because the numbers will be smaller. So I'm going to try to get 5 times 8 is 40. So I'm going to multiply the top by a -8 and the bottom by a +5. That'll give me -40 and +40, which is what I need to solve the system. Now this one I had not worked out in advance, so I'm going to have to punch numbers in the calculator while I talk. So 188.50 times -8 is -1,508, and that equals -40x plus, actually minus, 16 times -8, negative or minus 128y. Notice the sign change here because I'm multiplying by a negative. Also the sign change here because I multiplied by a negative. Now 254 times 5 is 1270, and that's 40x plus 100y. So now we've got a system of equations. We can add the equations together because that variable will cancel. Negative 1508 plus 1270 is negative 238. The x is canceled. Negative 128y plus 100y is negative 28y. And now we're going to divide both sides by negative 28. And we get that y equals, divided by negative 28, 8.5. So now we have to go back and remember what y equals. We go back. Y is her rate on a regular day. The question, though, was how much more is her holiday rate than her hourly rate? And we're going to need to now plug in, but I know exactly what you did. So if the answer is $2 more, if I add $2 to this, I get $10.50. So it looks like you picked how much is her holiday rate compared to how much more is it than her regular. Because you're now going to take this 8.5 and plug it in for y. I'm just going to use the top equation. 188.50 equals 5x plus 16 times 8.5. And now I'm just going to solve this equation so you can just watch me do that. So then again, the question wasn't how much is her holiday rate, it's how much more is it than a regular, and 10.5 or $10.50 is $2 more than $8.50. At his new job, Jeremiah can choose an hourly rate of $9 plus $50 weekly bonus for opening the store, or an hourly rate of $10 per hour with no opening bonus. The equations model his salary options. Excuse me. So we've got y equals 9x plus 50 or y equals 10x. And the question is, what does x represent? Well, it says an hourly rate of $9 or an hourly rate of $10. So when you talk about your hourly rate, that means he makes $9 per hour or $10 per hour. So x here would represent the number of hours worked each week. Y actually represents the total amount that he earns. And then the last one, oh, these are my favorite. Bethany has $3.10 in nickels and dimes. She has a total of 44 coins. What is the value of nickels that Bethany has? So we have two situations. We have the cost, how much a nickel and a dime is worth and how much money she has. And then we have the actual physical number of coins that she has. So I'm going to use N for nickels and D for dimes. We'll get real creative here. So the first example, $3.10. $3.10 is equal to the number of nickels she has and the number of dimes she has. Remember, the nickels are worth 5 cents and dimes are worth 10 cents. So if I take a number of nickels, oops, I used X, that's habit. The number of nickels times 0.05 and the number of dimes times 0.10, I should get $3.10 because that's how much money she has. The second equation is a little harder sometimes, maybe just to understand. It's just so different from the first one. So she has a total of 44 coins. That means if we take the number of nickels and we add it to the number of dimes, we should get 44 total coins. So here's your system. Again, we need the opposite coefficients, or the same coefficients to have opposite signs. So that would be either multiplying the bottom by negative 0.05 or multiplying the bottom by negative 0.10. I'll just do negative 0.1 because that number is just a little bit easier to work with. So my first equation doesn't change, and sometimes that happens too when you solve a system. You just need them to have opposite signs on the coefficients. So negative 0.10n minus 0.10d, and we do 44 times negative 0.1, and that's negative 4.4. So now we're going to add the equations together. Here the dimes are going to cancel. So 0.05 minus 0.1, negative 0.05n, that's what happens when I combine these, equals 310 minus 4.4 is negative $1.30. Divide by negative 0.05. And you're going to get 26. So she has 26 nickels. Now we're going to go back and look at the question. What's the value of the nickels Bethany has? So cool, we actually solved for the one we needed. Sometimes you solve for the variable you need the first time, and other times you don't solve for the variable you need and you have to go find it. So we know it's 26. Nickels are worth 5 cents a piece. So if you do 26 times 0.05, you get $1.30. Okay, so those are the questions you missed on your last attempt. I know that systems of equations are not easy, particularly when you have to set the thing up yourself, because if you don't set it up correctly, there's typically no way you're going to get the right answer. I've linked this video on YouTube because it was so long I couldn't send it through the email. Let me know if you have questions or if you don't pass your quiz again. Sorry that it took me so long to get back to you. I actually saw your email and then didn't have time to reply then, and somehow it just got pushed down my inbox. So I found it this morning and tried to get your reply to you quickly. So again, let me know if you have questions or if you don't pass the test.